video is going to take a quick look at a couple of the definite integral properties you've seen. In the first one, we have the function f of x is equal to 4x minus 7. The domain of this function is all real numbers, meaning that the function is defined for any and all real values of x. And then we consider the definite integral from negative 3 to negative 3 f of x dx. In other words, we're trying to go from the closed interval we have has absolutely no width. The interval from a to b is the interval from negative 3 to negative 3. There is no width there, and we have a property that says that therefore the area is 0, which kind of makes sense. It's essentially a rectangle, if you will, that has absolutely no width. If we try to approximate it using rectangles, we could never even get a rectangle. We have no width to work with there. In the second example, we're told that the integral from 0 to 4 of some function g of x with respect to x is equal to 9, and we're asked to figure out what happens when we take the integral from 4 to 0. Well, when you change the order of integration, when you change the order of integration, you change the sign. So from 0 to 4, we're moving from left to right, kind of in the positive x direction. And when we go from 4 to 0, we're moving in the opposite direction, from right to left, kind of in the negative x direction. And that flips that sign around, so that area would be considered to be negative 9. This can occasionally be a useful tool if you're trying to set something up where you want all of your answers to be positive. If you know in advance that an answer is going to be negative, you can flip the limits of integration to force a positive result.